This is Unit 0, Worksheet 5, number 3, the hands rubbing back and forth. We're going to kind of imagine, instead of rubbing back and forth, though, they're kind of rubbing in a circle. If you can imagine that. The reason I'm doing that is because then it keeps the speed of your hands constant. All right? Which makes for some weirdness in this problem. But if you look at the system, if we want to have an isolated system, the reason it says include yourself in the system is because you need to imagine what it is that allows you to make your hands move. All right, and we talked about this a little bit about how there's a process called cellular respiration that lets you get energy out of your food, and so that is a chemical process. So you need to include the person in the system, or you, and you probably need to include the surrounding air in the system. Okay. As far as what changes, the things that change is probably the temperature. When you rub your hands together and it's cold out, it keeps your hands warm. That would be the thermal energy account. And the speed, this is kind of a weird problem because the speed's not really changing, which means that we don't really need to include bar graphs for the kinetic energy, but because as a class convention we've established the ZRL, the zero reference level for kinetic energy, as being when something's stationary relative to the Earth, then we do need to include kinetic energy in our treatment of this problem. And then the last thing is, like I said, you're using energy from the food that you eat. So what's changing is, I don't know, we'll call it food molecules. Those would be like, sugars, fats, proteins that you've eaten, and you're changing those into something else in order to be able to use the energy stored in that food. So that will be the chemical energy account. Okay. Ooh, I forgot to tell you guys that sometimes we just draw a dotted line around our system on the diagram to kind of help us see what we're talking about when we talk about our system. Okay, so there's my accounts. I'm going to put these down here. Thermal energy, kinetic energy, chemical. New tool for the day. Doop. Yeah, it worked. Let's do it again. New tool for the day. Doop. Okay. All right, so we've got these three accounts, and we talked about, we'll go through them one at a time. All right. If we talk about the thermal energy account first, what do we know? Well, no, I'm sorry. Let's go with the easy one first. Let's talk about the kinetic energy account first. We know that the kinetic energy is constant because if you look up here at the arrows, we've got the same speed in all of these drawings. So I'm going to make the kinetic energy constant. It doesn't matter how many blocks we draw there. Sorry, I got tired of using the box tool for the blocks. So the kinetic energy is constant. We'll just put the same amount in all of these. If I had put one block or two blocks or three blocks, it doesn't matter how many blocks you put there, as long as you keep it constant through all the pictures. All right, the thermal energy, we talked about the zero reference level for thermal energy being 0 when the system is at its coldest. And in this class, it happens to be that that's going to, the coldest system, the coldest time for our system is going to be the very first picture. All of our systems in this class just get warmer. So at A, we will have 0 thermal energy, and that the temperature will go up as we rub our hands together, so the thermal energy will get bigger and bigger and bigger. Okay, and I drew 2 blocks as the maximum at the end. You could probably do more here. Let's do that. Just so you don't get the idea that you have to have 2. I'm going to put, I don't know, 3 blocks here. So 0 to 3, and then 6 here. If you think about that, think about this 0, 3, 6, you can kind of imagine what I would think at D. That tells me something about what I'm thinking in terms of this thermal energy in the system. So maybe you should be kind of thinking about that in the back of your head. What does that actually mean? And we'll talk more about that kind of stuff later in the year. But here we go. Now we're going to talk about chemical energy in the system. And that chemical energy is going to go down, right? It's going to decrease because as we use up the food that we've eaten, then those chemicals will change and put the energy into other parts of the system. So let's take a look at what we've got here. I've got 1 block and then 4 blocks and then 1, 2, 3, 4, 6, 7 blocks. So I have to kind of figure out how much chemical energy do I need. And I'm going to think about this backwards by looking at this last situation here at C and thinking, well, at C, let's pretend that my chemical energy is as low as it's going to get, which means that my chemical energy will be what I'm arbitrarily going to call the 0 reference level for the chemical energy. So there won't be any chemical energy at C, which means that I have 7 total blocks in all of my bar graphs. Okay, so that's going to help me by telling me how much chemical energy I need at B and A. So if I have 7 total blocks, 1, 2, 3, 4, 5, 6, just had to make sure I counted right. 7 total blocks at C, that means that in B I have 1, 2, 3, 4 blocks, so I need 3 blocks of chemical energy at B. Okay, and likewise at A, I have 1 block of kinetic energy and that's it, so I must have 6 blocks of chemical energy at A. Okay, and so there you have it. This is number 3, the rubbing of hands. An interesting thing is, earlier in class we did the pickup truck driving down the street. I don't know if you can tell, but this looks pretty much the same, doesn't it? Right, we have a constant velocity situation, and you're basically turning chemical energy, or you're turning fuel into the movement and the temperature change of the air and the objects.